Our example for advanced exponential growth is going to deal with population growth. So here's our example. A small town has a current population of just 5,000 people. The town's population is growing at a rate of 5% annually. We want to answer part A, what will the town's population be in 10 years? And part B, how many years will it take for the population to double? Before we can get started answering the questions, we need to identify our important information. So we have a current population of 5,000 people. That's important. Population is growing at a rate of 5% annually. That means our time period is 1 year. Right? That's going to be important. All right, so we're just going to write that down here before we start answering. We have A, B, and X, those same three variables from our intro. All right, A is 5,000. B is 5%. But remember, I need this as a decimal or a fraction. And so that is going to be 0.05 as a decimal, or 1/20th as a fraction. In this case, we're going to use the decimal because it's going to be easier to work with. And then X is our time period. That is 1 year. So whatever value we put in as our exponent represents years. All right, so we have that. The next thing we can do is rules. This would be our function rule and our now next rule. The function rule, using our A, B, and X over here, will be y equals 5,000 for A times 1 plus 0.05, and X is our exponent. All right? We can rewrite this as y equals 5,000 times 1.05. We just do the addition with an exponent of x. And then we have the now next rule, which will be next equals now times 1.05, starting at 5,000. So we have both of our rules now. All right. Now we can start answering the questions. All right. So I'm going to do that on the side here. I think I have some space. Not much. So actually we're going to move my page up. So right there. All right. And I'm going to do A here and B over here. So part A. What will be the town's population in 10 years? All right, that means all I have to do, replace x with 10 and calculate, put in our calculator. All right. So that is going to look like 5,000 times 1.05, and we're going to put 10 as our exponent value. When we put that into our calculator, we will get a population, or a result, of 8,144.473. I can't have a 0.473 of a person, right? Since I need to round to the whole number here, the nearest whole person, and this number is less than 5, that means I'm going to keep the 4 and ditch the rest of this. So my answer, the population, is going to be 8,144 people. So that's part A. Question B, I'll put over here. This says, how many years will it take for the population to double? Right? That wants me to find what exponent value will get a population of 10,000. All right, that's what it's asking me to find out. So what that looks like is we're going to solve 5,000 times 1.05 with an exponent of x equals 10,000. The best way we can handle this right now without learning other new math is guess and check. Try different values for x in the calculator. We already know that when x equals 10, we're at 8,144. Not enough. So it's going to be bigger than 10. And try some different values. When I did this, I went ahead and tried 15, and it ended up working. When x equals 15, we have 5,000 times 1.05 to the 15th is going to equal let's do this real quick. We have 5,000 times 1.05 exponent of 15. That gets me 10,394.6. So since our decimal here is bigger than 5, we're going to round up to 5 for the number of people. All right, so that will be 10,395. Now, just for fun, we'll go back in here and look and see what it is when it's 14. All right, and we can see that that's not quite enough. So it will take 15 as the exponent. So that means my answer is 15 years. All right. Please, if you have any questions, let me know, and check out the next video for an example for advanced exponential decay.